Welcome to Quality Time with MoreSteam. I am your host, Dan Swartwout. You know, there is a lot of great content on MoreSteam.com. You've got case studies, blogs, instructional videos. There's a lot to choose from. Myself, I'm kind of partial to the podcast. MoreSteam's monthly webinars are some of our most popular content every month. Our webinars tackle topics like understanding process capability in real-world applications and mastering destructive gauge R&R. Great topics. Today on the podcast, I am joined by Lean Six Sigma Master Black Belt Kevin Keller. Kevin is a frequent host of the monthly MoreSteam webinars, and in this episode of the podcast, we cover topics like statistical hypothesis testing, control charts, understanding variability, response surface methodology, and so much more. Kevin is very knowledgeable. He's also super engaging. After listening to this episode, check out some of Kevin's webinars that are listed in the show notes. You'll like them a lot. And now my conversation with Kevin Keller. Today, we are lucky to be joined by certified Lean Six Sigma Master Black Belt Kevin Keller. Kevin, welcome to the show.
Thanks, Dan. I appreciate it.
Kevin, you're originally from the Missouri area, correct?
Correct. I grew up in North St. Louis County, and I joke, except for the 80s, I've lived in this area all my life.
I've lived in Central Ohio all my life, and I think part of the time you weren't in Missouri was in Central Ohio, correct?
I was. I went to University of Missouri-Rolla for undergrad. Then I worked in Dallas, and then I left Dallas to come to Ohio State. So I was at Ohio State 88 to 89.
What were your impressions of Ohio State, your time that you were here?
I actually loved it. I regretted not going to Ohio State as an undergrad because I probably would not have gotten as good of grades as I did in undergrad.
A lot of distractions at Ohio State, Kevin.
A lot of distractions at Ohio State, but it was a wonder. I have zero regrets. I think it was a wonderful choice on my part. I loved it.
How did you get involved in Lean Six Sigma?
So I originally got my bachelor's in chemical engineering and quickly discovered I despised the whole engineering application, with one exception: is anytime I got data, then I loved engineering. And so at some point, I had taken a class on Taguchi methods while I was at Texas Instruments and fell in love with the concept of designing experiments and doing statistical analyses. And I asked the question, how do you do that? And they said, get a degree. And back in those days, that was the only way you did statistics, was to get a degree. So I got a degree at Ohio State in applied statistics, and I was hired by a company called MEMC Electronic Materials. And essentially, we didn't have Lean Six Sigma back in those days, but we were doing that and much more.
And then eventually you ended up back in the St. Louis area with a company that's somewhat associated with the St. Louis area, just a little bit.
Yeah, just a little bit. So actually, MEMC was in the St. Louis area. But then, I went to work for Anheuser-Busch in 2004, and in 2008, we were integrated with InBev. So I spent the rest of my corporate career working in the beer industry.
And so now you are out of the corporate industry. You're a consultant, you're a teacher. And how did you get involved with MoreSteam?
So AB was a client of MoreSteam's back in the day. And so I had met Bill Hathaway and Kathy Miller and others while I was there. And one of the things, eventually I joined the continuous improvement group at Anheuser-Busch, which is its own story of itself. But one of the things they wanted all of their master black belts to do was to actually be certified. So they sent us to MoreSteam to be certified in Lean Six Sigma. So I went through all the MoreSteam training that everybody else does. I went through it too.
And now you work on MoreSteam client services. So you actually help teach the curriculum now. How's that going
Correct.
from a student to a teacher of the curriculum?
The biggest benefit, I had a client last year who was going through the process and they required all of their students to take the exam. And none of them had taken a MoreSteam exam before. And so having gone through the process, I was like, okay, this is the way you can be the most successful going through the class, going through the materials to be successful on the test. So that was fun.
And as a master black belt, you do consulting work as well as teaching and coaching, correct? Now,
Correct.
I asked Maria Fry a few episodes ago about that as a master black belt doing that kind of consulting work. And of course, without revealing anything you cannot reveal, Kevin, tell us what that is
Right.
like being a consultant in that level. What do you do? What do organizations look to you for?
I span the gamut. Um, I would say probably about 2/3 of my clients are non-manufacturing, which Lean Six Sigma emerged from manufacturing, and many examples that you read in coursework are manufacturing. But I have spent the majority of my career applying it in non-manufacturing roles. So it's really helpful to take all the different tools and go, these tools don't really apply here, but these tools will help you tremendously. Um, the methodology is the same. There's really no difference in methodology, but tool usage changes between manufacturing and non-manufacturing. But I love it. I was just on a call a couple of hours ago, and they're talking about different ways that they could go about designing an experiment. And I'm like, I have no idea about any of the technology, but I'm there at the ready when they're like, okay, this is what we want to accomplish. How do we accomplish that? Then I enter
And
in.
that's when you step in.
Yep. So it's fun. I love it. I have learned so much about so many different things. It's just, to me, it's fascinating. I love any TV show about how do you build things? How do you make things? I am totally invested in that. I love it.
Now, what about in your personal life, Kevin? How do you use some of these principles in your day to day life, maybe around the house or with your family or with hobbies that you
I,
have?
ironically, my wife is much better at 5S than I am. I can teach about 5S, but she's the one that does 5S in our house. You go around, everything's got labels, everything is organized. If you could see, if I just reversed my computer and you could see the mess that my office is, you would go, how does this guy teach 5S when it doesn't look like 5S?
Yeah, my office right now could definitely use a 5S as well. One time I remember one time I was cleaning out my office. This was several years ago, and I had found a pizza coupon for a pizza place that had closed 5 years prior. And I'm like, maybe
Yeah.
I should have done this 5S a little sooner.
Yeah. But I think we all use the principles in everything that we do. For me, I look at any problem and I go, okay, what's the root cause? Not I'm not going to get angry at the person, but I'm looking at why did the situation happen and how do we navigate our way out of this? So if you go to, a car dealership or anything else, there's always problems and you're looking at it through the lens of Lean Six Sigma.
Now, one of the things you've been doing with the lens of Lean Six Sigma is hosting a series of webinars with MoreSteam. How did that come about? Because I know that you've hosted webinars in the past, and now it's becoming a much more regular thing.
Right. So I find it fascinating. Every company I worked with did not want their employees going out and doing papers, publications, presenting. Everything was trade secret. We don't want anybody to know what we're doing. And so after I retired from the corporate world and went independent, I thought, oh, I want to get involved in some way. And when the pandemic happened, it was ideal. Every company is doing webinars and making information available. So I started doing webinars for MoreSteam. And Bill Hathaway kind of said, Kevin has a great way of explaining the hard and making it accessible to everybody. So it's just been a evolution over the last few years, coming to that point where I'm now doing technical work for MoreSteam on the video series.
One of the things I'd like to talk about is some of the topics of your webinars and how you do make the complicated accessible. So I want to kind of go over some of the topics that you've discussed in past webinars, future webinars,
Mhm.
and give people a taste of what they can experience if they join you on one of these webinars. And besides that, Kevin, and we'll get to this a little bit later, you are a particularly engaging speaker because you have a interesting performance background that we will get to in a little bit, but just that's a tease for everyone out there. One of the reasons Kevin is so engaging, not just on this podcast, but in these webinars. So, kind of going over some of the themes in the webinars, let's just talk about a few things that you talked about, such as now, how can understanding variability in manufacturing processes help companies improve their operations? That's something we've talked about before.
Of course. Um, this is where students who come into Lean Six Sigma turn off because they go, I don't need Six Sigma capability. So for me, the question is always, when failure is not an option, you need Six
Right.
Sigma, the variability reduction. When failure is an option, then there is some risk level that a company has decided is acceptable. It's acceptable to them. It's acceptable to the customer base. So my last corporate job was making aluminum cans for Anheuser-Busch. We make millions and millions of cans a day. If a can fails where it crushes or it leaks, it's annoying, but it's not catastrophic. Nobody dies. And so, it costs the company a little bit of money, and okay, so what? But if failure is not an option, so for example, there are a few failures that if they happened in the marketplace, then that would be catastrophic, where you have a market recall or even worse, those failures must be prevented. So every company has to decide what sort of variability is acceptable. Now, where Lean Six Sigma provokes you to think differently is there are hidden costs. And there was an old quality guy by the name of Feigenbaum who coined this phrase, the hidden factory. And his hypothesis was that 20% of costs associated with variability are hidden within a factory. You don't know they're there. And so if you start thinking about, do you have a quality inspection department? If you do, that's because your variability is too much. If everything was perfect, you would never have to inspect. Therefore, you would never have a quality department. If your quality was perfect, if you had no variability, you wouldn't have any warranty costs. You wouldn't have any complaints by customers. So at some point, you have to decide what is acceptable and what is not acceptable. You think about, okay, we have a little upset. We can rework the material. That costs money.
Right.
And so it becomes a very much an economic discussion of how much money can we save by improving variability? And once you start thinking that way, you realize, okay, we could probably get better at reducing variability. But how far you go is really an economic decision. Why would you reduce variability spending millions of dollars when we save tens of dollars? You wouldn't do
Right.
that, but you would spend thousands of dollars to save millions of dollars. So that's an economic decision that every company has to go through.
And you were involved in those decisions in the past, I'm sure. And as a consultant, I'm sure you're brought in to help make
And
those
let me let
decisions.
me and let me kind of jump in on the first part of that. I made myself a part of those discussions because statisticians by themselves don't naturally think in terms of the language of the business and money. They go, okay, we have a capability, a CPK of 0.8. We needed to get to 1. Why? Because that's a target. That's not helpful to a business. What's helpful to a business is if it translates to the bottom line. And you have to be an advocate for that. So I'll give you a counter example. When I was with Anheuser-Busch on the lid side, lids are highly capable. We're talking parts per billion, if not parts per trillion defective levels. we're spending a lot of money on quality. And I went to our chief operating officer of the division. I go, why are we spending so much money? We don't need to spend that money. We're capable. Let's move on and spend that money somewhere else. And so when the Lean Six Sigma black belt or master black belt or whoever it is comes to the table and says, here's a better way of spending our resources and thinking about that, that's when they truly bring value. So as a consultant, that's what I do as well.
Kevin, you mentioned the term CPK. Could you explain for those who might not be familiar what exactly that is?
So yeah, sure. So there's process capability indices, and there's a variety of them, but they deal with how capable are we in meeting the customer's expectations. And so when you're in manufacturing, I always talk about we're putting product on a truck and shipping that product somewhere. Now, it could be a service level agreement as well, where you're providing some service within a period of time. But the classic example is making product. So if I have 100 parts and 5 out of the 100 parts are defective, typically we talk about it in terms of yield. But there's capability indices, which are numeric numbers that are tied to that sort of analysis. So statisticians tend to talk about PPK and CPK, but it's similar in some sense to yield.
Got it.
There's subtle differences, but it's close enough.
We're talking statistics, Kevin. You're a statistician. Could you give us kind of a simple introduction to statistical hypothesis testing and its role in process improvement?
Of course. So part of the scientific method is that you have a problem and you need to solve that problem. And through analyzing data or brainstorming or some sort of diagnostic journey, we ultimately come to a belief of, okay, I think temperature is the cause. If we increase temperature, the problem should go away. Fine. We need to test, is that truly the case? And so hypothesis testing is about coming up with what is it that we want to prove and making sure that we have sufficient number of samples in order to establish, is that true? Now, can we ever establish it with perfect confidence? No. So we use data to kind of say, okay, the risk level of being wrong is pretty low. We should go ahead and make the change.
We're talking about statistics, and this is a very specialized, highly specialized field. You obviously have an advanced degree in it, and you can talk about statistics on a level that is far above my head, far above the head of many, many people. So how do you simplify those statistical concepts for people who aren't experts in the field to make those insights more impactful?
So when I'm in a classroom setting, I'm highly aware of where each of the students, their departments, their jobs, what they work in, and I'm instantly trying to figure out what they do in their job, what kind of data do they have available, what decisions are they making, and I will attempt to put the problem in their language so I have the best chance of success. But I appeal to their day-to-day job. So for example, one of my favorite examples that I pull out every time I teach hypothesis testing is we learn about this concept called alpha error. And alpha error is the error that happens when you think that there is a significant difference, that whatever you tested, I think that's true, when in fact it's not true. And that is an error that you can control. So if I'm just exploring around, I could choose that error to be 10%, which means 90% of the time, if I think there's a difference, I'm right. And 10% of the time when I think there's a difference, I'm wrong. If I am an engineer and I'm just looking for stuff, I might have that confidence level. But if I have to present to the CEO and I could lose my job if I'm wrong.
Right.
90%, there's a 1 in 10 chance. I don't want to lose my job in a 1 in 10
No.
chance. So we learn about different levels of confidence. And so the example that I was faced with is I always tell my students, never ever go beyond 10%, 15%, 20%, never ever ever do that because it all falls apart. And one class, this woman raised her hand and she was in product development. She said, my department uses 20%. Where if we get 80% confidence, we go ahead and launch the project. And the class just stopped. And I always think about this as walking a tight wire and you don't have a net. Do I go forward or do I just hide in my shell and ignore it? Now I always go for the tight wire with no net. And I'm asking her questions about, so you go ahead and do this. All right. For all those new product launches, how many are actually successful? And she goes, about 50%. And I went, exactly why we never go beyond 10%. It's because it all falls apart after that. And so things like runs rules in SPC, where you have 8 in a row above or 8 in a row below. How did they come up with those numbers? And I'll have somebody pull out a quarter and I'll say, okay, I want you to flip that quarter. I'm going to continue talking to the class. When you get 8 in a row, you stop us. And a couple of minutes later, they go, this isn't happening. Exactly. And so I do things like that, trying to make real world examples of these statistical concepts that seem pretty obscure.
When you get to talking about earlier, the bottom line, 20%, 80%, and only 50% of the projects are successful, I think that goes back to why it is crucial to make precise and valid statistical inferences in business decision-making, because it does impact the bottom line the less confident you are.
Absolutely. And so one of the things we talk about a lot, and when it comes to the statistical rigor, you go through statistical rigor, but at the end of the day, all the assumptions are violated. So it's a best guess. And so, for those who have studied, you learn about p-values. And if you're not quite over the hurdle yet that you can say, yes, there's a difference, I talk about the motivation as to why you might go ahead and say it's significant or whatever. But the bottom line is, let's say you got a p-value of 0.11 and you needed to be 95% confident, which means a p-value of 0.05 or less. I tell people, present that p-value at the meeting, and senior management can always go, close, we're going to go ahead and take the risk. That's okay. You've done your job in testing it out, finding out what's the risk, and management can always change their mind and make a decision anyway. But it's not your call. It's senior management's call. And I tell all of my students, your most important job as a black belt or a master black belt or a statistician is to listen to the business. The vice president or the director goes, we got a problem.
Right.
And they never, ever talk statistics. They just say, we got a business problem. You have to convert that to a statistical problem, take that statistical problem, convert it to a statistical answer. And most belts can do that. But what they struggle with is taking that statistical answer back to a business solution.
Right.
And that's the true value of a belt or a statistician who understands what it means for the business. Vice presidents don't want to hear p-values. They don't want to hear null hypothesis. They don't want to hear about ANOVAs. They just want to know, what do we do?
Communication is a real skill set of a master black belt or a black belt, being able to communicate in a language that people can understand. Are you able to learn that? Does that come naturally? Are you able to teach that?
I think, I try to stress it in all my classes that vice presidents don't want to hear about residuals. They don't want to hear about ANOVAs. They don't want to hear any of that because it just goes in one ear and out the other. What they want to know is, were you able to solve the problem, and what should we do? And they're trusting that the statistical underpinnings are there. So that is lessons learned. To go back to your original question, those are lessons learned. What I try to do in my classes is coach people. Don't show that. Don't show that. Don't show that. Don't show that. Have that in backup. This is what you want to tell your VP.
These are the kinds of insights we can find in your webinars, Kevin, usually on Wednesdays. And I know that we send out information about these webinars to the MoreSteam newsletter. You can find information on LinkedIn. I want to talk about a few other things that you cover, Kevin, in your webinars. Something that we talk about a lot and maybe not everyone understands are control charts. So what exactly
Sure.
are control charts and how do they assist in maintaining that process quality?
So it's a control chart. Any of these topics can go in 5,000 directions. So I'm going to try to keep it pretty focused. In manufacturing, and now that's not everybody. In manufacturing, we expect to get the same result each and every time. And so, but we don't. We don't get the same result each and every time. So what SPC does is it says, what's the natural variability of your data over time? And then it says, as long as it's within these sets of limits, it's behaving the way it should behave. If it all of a sudden shifts or trends up or trends down, or you get some unusual observation, then the chances are there is a root cause. Sometimes we're not smart enough to figure out what that root cause is. And I had a client one time, or not a client, but a customer tell me one time, yeah, it's probably about 20% of the time we actually know what happened. And there's a valid reason for that, is that when the team members are out on the line and they gather the data, they're busy.
Right.
And so, yep, got a data point, and yep, it's out of control, and I've got to get this thing moving, and I've got to do this and that and the other thing. And ideally, we tell people, oh, stop and investigate, but that's not reality. Reality is, I'll get to it eventually, which is never.
The line keeps
So the
moving, Kevin.
engine-
The line keeps moving.
I know it keeps moving. The engineer comes along, or the manager comes along a day or two later and goes, we had a problem. I wonder what caused that. Well, by now the problem is gone. So maybe it was a slug of something, or it was just an unusual combination of things. We don't know. It's when it's sustained that we go, okay, something has changed. Let's go figure it out. But for that one observation, it's there and gone, and we'll never know what actually happened there. So with manufacturing, we expect the same result each and every time. But there's a whole different world that we can use SPC, and that's when we'd like for the results to be the same, or maybe we want them to be increasing. If we were tracking sales, we would want sales to increase, but perhaps it's relatively stable. But that's where the moving range chart comes in, is looking at the change from observation to observation. That chart tells those people far more than the actual individual chart. And so we go into that, how you can learn how to use the moving range to your advantage.
Kevin, this is really fascinating stuff. And for somebody like me, who's a definite layperson, you're making it somewhat accessible to me. So for somebody who's got even more knowledge, this has got to be exceedingly helpful. And this is the kinds of things that you can hear and listen and interact with you during these webinars.
Yep. So I will never forget sitting in a sales meeting at my former beer company, and they were talking about the decline of a particular brand. And at some point, they called an all hands on deck meeting where it had dropped below a certain target value. And okay, what are we going to do about this? And And people were going, well, it's because this competitor took this pricing action, and it's because of this, it's because of that. Nothing had changed about the process. That was going to be predictable that one day it would cross that line. And the moving range chart just said, yep, everything is doing exactly what we would predict it to do. Nobody was saying, how are we going to fundamentally change the way the public perceives this beer brand? It was, well, we'll take some pricing action. Well, it's not going to do anything. So helping people understand from their world how they use these tools is really hard, but it's necessary. And so for those people that deal only with manufacturing, they struggle when they go into service projects because they expect every number to be the same, and that's not true. So you kind of have to learn, and I make it sound easy, but I've got 40 years of doing this and experiences and lessons learned. So it's not as easy as I make it sound.
Kevin just said it's not as easy as I make it to sound like, but his microphone didn't pick that up very well. Some things the microphone always picks up well are the words to this short break. MoreSteam's enterprise process improvement platform includes the tools, training, and software you need to transform your organization into a problem-solving powerhouse. Join the ranks of Fortune 500 companies that trust MoreSteam for their enterprise process improvement. Our integrated approach featuring training, project tracking and execution, simulations, and statistical analysis empowers your team to create a culture where structured problem solving becomes second nature. Visit MoreSteam.com to learn more. And now back to my conversation with Kevin Keller. Real quick, another thing I want to touch on, response surface methodology. That's something you have covered, something you will cover. Can you share some examples of how response surface methodology has been used to enhance product performance or efficiency? And just an overview of quick overview of what response surface methodology is.
So response surface methodology is primarily in a science-based process where you have chemistry, you have things that are interacting with each other. And so, when you see these real fancy contour plots where you go, okay, so much of this chemical and so much of this chemical and a certain temperature gives you a certain yield. And so when a manufacturer decides, okay, we're going to create a process, sometimes it's really quick and they just kind of turn some knobs, they get something to work and they go, this is our process. But we know if we turn certain knobs, we might be able to get a better performance. But we're in the heat of battle just trying to make product, get it out the door. So these processes become locked in place for a certain period of time. And the economics of the time says, don't work on it. But at some point, we get squeezed on a budget perspective and we go, let's see if we can find more opportunity. So response surface methodology is a strategy to systematically work through that space to find the sweet spot. So one example that I did years ago was when I was involved in making silicon wafers. The technology that we used was about 30 years old. From the dawn of silicon wafers, that was the technology we were using. And there was a new technology developed and we fired it up just like the old technology. Didn't work. And so what we had to do was systematically walk through carefully changing the levers to improve performance. And as we went through that, we started learning, okay, these are the relationships. And the more interactions, the more nonlinear the responses, the more response surface methodology helps out.
It sounds, Kevin, like it's a combination of science and art to an extent.
Oh, yes, absolutely. There is a bit of art in doing experiments where you over the years, you start learning this is probably not going to work because I've seen other experiences similar to that. And then there's the science part, which is we know certain things. So yeah, it is a bit of both.
And you have an artistic background as well. As I mentioned a little earlier on, you can find out more about Kevin because on Wikipedia, it notes his Hall of Fame induction in 2020, as you are one of the most renowned individuals there is in barbershop music, barbershop quartets, barbershop orchestras. Could you tell us a little bit how you got involved with that? And I want to know a little about how maybe you use some of these principles on that, because Google Kevin Keller and Barbershop, you will see all of these videos where they say the arrangement done by Kevin Keller and what that signifies.
Yeah. So I joined the Barbershop Harmony Society in 1978. I'd always loved the
Still in
music.
high
And when I
school.
found out, still in high school, yes, good math. And so I'd always loved the music, the sound of it. And I got involved and I have never stopped since. I got involved in arranging barbershop in the 90s. And there is a strong correlation between math and music. Both are very pattern based.
Yes.
So if you're a musician and you're a math geek, it's very, very simple to put that together. But yeah, I guess how have I used what I've learned on the professional side is more on the administrative side. I've done a lot of work in uh, doing membership studies, and I've used a lot of statistics with that. Pretty much a lot of reliability statistics where you're dealing with people who are still living, who are still participating, which is very much censored data like you would use in reliability. So I've done a lot of that sort of work. Um, I've been involved with administrative sides where we're looking at other data analysis. And so one project I worked on several years ago was teaching the corporate organization about lead. So how do we do the same with less?
If you look at your time in barbershop, what would you consider your pinnacle achievement, aside obviously from being in the Hall of Fame? An award you've won, an arrangement that won an award? I mean, obviously you're out there doing this. This is really exciting.
Yeah. I perhaps not a pinnacle, but one of the things I take great pride in is for the first 60, 70 years of our existence. I've lost track now, but I can tell you the year 2010 or 2013, excuse me. So prior to that moment, when a judge, and I'm part of the judging system, when a judge writes down the number, that's it. It never gets changed, altered, or anything like that. And I recognize that the variability in the judging program often had a significant impact on the competitors. And so I led our judging community from a position of we don't want to change our scores to we should change our scores. And then we figured out how to do that. So today, as contests go on and we have a score that seems to be out of bounds with the rest of the panel, that gets flagged and everybody can talk about it and figure out, should it stay or should it change? And so I think that's one of things I'm most proud of.
So the judging system is more uniform, regardless of whether the judges or competition takes place in Columbus or St. Louis or Tacoma, Washington, or San Antonio. And that was part of that, using your Lean Six Sigma principles.
Yeah, now I can't take credit for all of that because that has been an evolution throughout time. But at some point, everybody goes, well, this is good enough. And then you look at it and go, but it can be better. And so from that perspective, with the continuous improvement eye, one of the things that I did back in 2008, 2009, was I had believed that you could statistically evaluate each judge. Now, no judge wanted that. No judge wants to be under the scrutiny, somebody's looking at your scoring performance and go, oh, you have opportunity here. But we implemented that in 2010, and we have seen the benefits that now you don't see the same scoring behaviors that we saw 13, 15, 20 years ago. Pretty much everybody is uniform. That doesn't mean there isn't variability, but pretty much everybody is uniform in the way that they're rank ordering the performances. So that was part of, I guess that's another thing that I've done using my statistics background.
Kevin, this has been a great conversation. Anything we haven't touched on with the webinars that you would like to touch on, or just a reason why people should take part in these webinars, what they can take away from these webinars as you pick some of these topics to make a lot of these really difficult concepts accessible to people?
And I think what you just said is the reason why I feel passionate about it. When I was working in the corporate world, I was in control of everything. So, if you're in control of everything, people think just like you, where, okay, I'm going to do it this way. And it's very pragmatic and it works and helps solve problems. It wasn't until I became an independent that I realized that a lot of people are being taught theoretical statistics that in the real world don't work.
Right.
And then when they don't work in the real world without any sort of, then what do I do? People just say, well, it doesn't work. And that's not true at all. You can do a lot of things with imperfect data. And so what I try to do in all of my webinars is go, this is the theory. You've all been taught the theory. Theory doesn't work in the real world. How does it work in the real world? Because data is messy. Data is ugly. How do you manage through that? So that's my goal, is to help people manage through that.
And Kevin, we have webinars coming up with you on MoreSteam that are live webinars that people can join. We have webinars that are archived in the website that people can go back and see. Kevin, I appreciate this time talking about your background, talking about the webinars, really giving us an overview of statistics and trying to make statistics simpler for somebody like me who took one statistics class as an undergrad at Ohio State.
Thank you. I appreciate it.
Thank you, Kevin.
And thank you for listening to Quality Time with MoreSteam. You can email the show at qualitytime@moresteam.com. And if you enjoyed the show, please leave a rating or review on your favorite podcast service. Also, please go ahead and visit our website, moresteam.com, to learn about the software and tools that can help you solve problems, eliminate waste, and do things better. We'll be back in 2 weeks with more Quality Time with MoreSteam. Thanks again.